Now that we have discussed about locating a point in various regions of the quadrant 1, quadrant 2, quadrant 3 and quadrant 4, now comes on what would be the position if I would like to locate a point on the horizontal axis or the vertical axis itself. So today's session is about locating a point on the horizontal axis initially. Locating a point on x-axis, the horizontal axis. So let's recap with the Cartesian plane. Now with the introducing of the Cartesian plane, x dash and y dash, with origin being the intersection, let me just take 1, 2, 3, 4, minus 1, Now I have these points located out here in the Cartesian plane. Now I wanted to locate a point exactly out here. Here lies Q1, here lies Q2, here lies Q3 and here lies Q4. Now here the question is to locate a point P at this region. So how do I locate this point P exactly in between? So I understand that this point is clearly around 2 units from 2.5 units from origin. So I have this to be this resistance being 2.5 units to the right. And now after moving 2.5 units to the right, it doesn't move up or down. That means there's no change in the y coordinate. It is 0 itself from the initial position. So my initial point, which is moving 2.5 units to the right, makes me understand that my point P moves 2.5 units to the right and doesn't move anywhere down. So I have my 2.5 which comes out here as 2.5, 0. So the point which moves towards right on x-axis is 2.5, 0. So I could identify the coordinates of P as 2.5, 0. Let's take another point as a review exercise. For example, I take this point -3 and let's see the point -3 on x-axis. How do we locate this point and what are its respective coordinates? I clearly see that this point -3 is -3 units or 3 units to the left, and therefore this has, say, the point Q out here is nothing but -3, 0, because this moves along x-axis but there's no change up and down. So this doesn't have its y affected as in the previous case. Only the x coordinate gets affected. Therefore, for point Q, the abscissa is -3 and the ordinate is 0. So what do we understand from seeing these two coordinates? What is the learning outcome? Clearly, we see that if we just try with another coordinate, say, let me take out here as R, then clearly I see that the coordinates of R are 1 unit to the right, no change in y. Therefore, 1 unit to the right, so plus, and then no change in y is what we observe. So what do we observe as the learning outcome in all these 3 coordinates is the biggest question out here. When we investigate the points P, Q and R on x-axis, we see that the point P is 2.5, 0, point Q is -3, 0 and point R is 1, 0. We clearly see that each of the points have their y coordinates as 0 because any point on x-axis, there's no change in y, but there's a change in x. So any point on x-axis, there is a change in x, but there's no change in y. Therefore, my note is every ordinate of a point on x-axis is always zero. So this is the learning outcome in case of any point on x-axis. Every ordinate or every y-coordinate of a point on x-axis is 0. So any general point you take on x-axis would be in the form x, 0 for all x belonging to the real numbers on x-axis is what we learn as the learning outcome. Any point on x-axis is in the form x, 0. Now that we have discussed about locating a point on x-axis, the next question comes on what is the position when I locate the point on y-axis. When I locate the point on y-axis, let's see the investigation on how its coordinates change respectively, as in the case of x-axis. So let's revisit the Cartesian plane. Imagine the Cartesian plane x, x dash, and y, y dash. With each of the points taken in this form. Now with this coordinate system, let's see any point I pick on the y-axis. Say for example, I have this point P located at this position at 4. So let's see what would be the coordinates of this point P located at 4. Clearly, when I see this point P along x-axis, I see that this point starting from its initial position does not change along x-axis. It directly jumps up 4 units towards y-axis. So this clearly makes me understand that there is no change in x, but there is a change with a jump of 4 units up in y-axis. Therefore, I see that the coordinates of P, which jump 4 units to the top with no change in x, clearly makes me understand that its x coordinate does not change, so its initial point, which is 0, remains the same. It's only its y coordinate being changed jumps 4 units up to the positive side, and hence it affects with 4 units out there. Is how we understand the coordinates of P being 0, 4 out here. Let's try with another example. So for example, I have a point out here which is denoted by Q. Let's see the coordinates of Q. Now as I see the coordinates of Q, as in the case of P, clearly I see that Q jumps 2 units down, and therefore without affecting the value of x remaining 0, the y gets affected by moving 2 units down to the negative side, and hence my Q is this. Let's investigate with one more example. Say I take this to be R. Let's see the coordinates of R. My R coordinates does not affect with x as in the case of P and Q, and hence x remains same, and then my y coordinate jumps 5 units to the top, so the positive 5 comes into the y coordinate. Is how I get the abscissa and the ordinate for each of the points P, Q and R. Now comes the question, what is the outcome of this investigation? As clearly we see that in each of the outcome, the x coordinate is 0 and the y coordinates change accordingly with the position or the locating of the point. So each of the x coordinates being 0 implies that for every point on y-axis, the abscissa will be 0, unlike the x-axis. So here I note every abscissa on the y-axis is equal to 0 is how I make the outcome. Every abscissa on the y-axis must be 0. Just like for x-axis, every ordinate on the x-axis is 0 and every abscissa on the y-axis must be 0. It cannot change because any point on y-axis changes doesn't affect the change in y. Any point moving along x-axis doesn't change the effect of y, and hence for x-axis y coordinate is 0 and for y-axis x coordinate is 0 is how we understand through the applications. An example problem connected with the points on y-axis and x-axis.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.